Two foot on truck.
Thanks, John.
Yeah,
Get closer, fool.
I said, YouTube ready or what?
Yeah, YouTube ready.
Tell Louis' mom stuff. Come on, Virgil.
Hey, man.
Go to Facebook, yeah, Facebook.
Live?
Live, oh, live.
Everybody got safety glasses?
Safety glasses.
Safety glasses.
The glasses don't count. You gotta be like this
Mama?
right here. X-ray vision.
Yeah, that's right. I got you on candy camera.
Okay, what's the code?
You know what I'm talking about? This is glasses with glasses.
So it's down. Oh, yeah, glasses over glasses? Yes, Jonas is that? Hey, compare the
Yes, that way.
pre-Cat 02 signal to the post-Cat 02 signal and see what it looks like. Right, you can do that on the Genesis, right? All right. Battery leads, positive, negative. Okay. A lot of these scopes especially use this ground for a good ground signal for everything you're doing.
Yeah. Negative left, positive first.
You're right.
All right, you got a hard pulse right there. Good.
All these scopes measure vacuum.
Vacuum force?
That's for the vacuum? Vacuum.
Yeah, I need somebody to check out
Yeah, check there.
hose and vacuum team.
Yeah.
Well, anytime you hook your hand, you want to tee it in so you don't disable that system when you're testing. So if somebody go get a vacuum hose and a vacuum tee, you hook that up.
Córrele, mija. No, está acá.
Mandas, le cambias el motor que tiene el tuyo y lo pones a ese y lo mandas al ticket point a 300 bolas.
What's that ticket?
O busca para el core.
You want the light? You get good
Te
picture.
lo pones para atrás, güey, y ganas 600
Pero no tiene, güey. ¿Qué lo voy a poner atrás?
El carro tiene eso, nomás que el güey que está vendiendo dice que tiene eso supuestamente.
No sirve, ¿no?
Que no sirve.
Que no sirve o que no lo tiene.
Que no le sirve, güey.
Pero si lo
Ponlo,
tiene.
sí lo tiene.
No one just go to pick it for it.
Y tiene rines de primero, 18, güey, bien chingones, güey. Se ve chingón. Míralo, güey. Y ya, tú lo conoces, no quieres que
Oh, I wouldn't bend over right there, you
Hey,
know.
don't bend over right in front of him.
I know, might take it the wrong way.
estaba en la neta. Hand probe. Hook it up.
Tell that shit.
Some of these machines use the amp probe to calculate relative compression. To tell you that all the cylinders got an equal amount of pressure. And they're doing it through the amperage draw. Okay?
Let me record though.
Record good.
Yeah.
Man, shaking too much.
Use your reference.
You're going to put this up on YouTube, right?
For sure. Nah, hell no. People on YouTube, they don't deserve this. We're wasting our time here. It's for us and only us.
We're going to get stuck with a couple million views.
Can you put a freaking, what do you call it? The online celebrity?
You see my phone? No? Come up too quick. Hook up your vacuum gauge. Other machine, you actually can see
Hasta la verga.
vacuum gauge, right? Secondary pattern hookup.
Secondary.
This will go over the coil wire.
The coil wire?
Oh, all right.
You also have two leads to hook up. One is to the positive side of the coil.
Which one is it?
I believe this right one. This go over the negative side of the coil. Where you get your RPM.
Positive?
I believe the blue one is your tag signal, RPM. Okay. That's where you guys were hooking up for RPM before, right?
Yeah, that's right, yeah.
I don't remember. Right? That's the negative side of the coil.
Yeah.
When you're getting the RPM off the coil, it's the negative side of the coil. You get your dwell, your RPM from there. Okay.
No pressure, Papo. You're on camera. No pressure. No pressure.
Piggyback right, bro. We only sold
Hey, you can always watch the video later.
I know. It's a little later.
So just calm down.
It won't hurt, though.
Se puede ni poseer.
This lead goes over number 1.
Hey, man, I'm trying to learn.
Number 1 spark plug wire.
Okay.
We went over the coil wire. We go over number 1 spark plug wire. Make sure it's over the wire. Make sure all your leads are routed away from the fan and fan belts and other rotating. That's how you get it. On the machine, we need to come over here and select the number of cylinders. This machine will select 2, 3, 4, 6, and 8. This is pre-V10 and V12. Right? Notice there's no 5-cylinder scale.
Whoa, so how do we do it for my Volvo?
That's why I didn't use your Volvo. The machine's not capable of working on your Volvo per se. It will show the patterns.
It's not a number, that's why.
Okay?
We don't like
Well, they do have an odd number. 3. Are there 3-cylinder cars out there? Yeah.
I think Volvo. Hey, Swedish.
Metro or something?
Yeah, the deal.
Yeah, 3-cylinder engine.
The deal.
I saw it in the movie.
2-cylinder engine. Yeah, we got a number 2-cylinder engine.
Excuse me.
4.
Sorry.
There was no selection for 5.
Making me feel bad.
6. There's no selection for 7.
7.5. 5.5.
Yeah. This is totally right.
A lot more.
I don't know what kind of patterns you get if we get anything. Anyway, it is 4-cylinder, so like that. 2-cycle, 4-cycle. But there are 2-cycle engines. Yeah. No. 2-cylinder, 4-cylinder, 8-cylinder.
They're illegal in California, right?
Huh?
Are they illegal in California? No, they're not.
No? There aren't too many 2-cycle engines on the road anywhere in the United States.
I got steady hands, man.
Scooters that are legal, they're 2-cycle.
Hey.
Right. Yeah. We're going to come over here, secondary pattern, to go low height or high height. We're going to look at that. We make it bright, dim. Usually try not to go as bright as you can. Try and go about a medium brightness so you can see everything. We can move the line horizontally back and forth. We can move it vertically.
I like vertical.
Right?
It just looks cool.
Make my own pattern, right?
Yeah.
We're going to control the horizontal. We're going to control the vertical. We're going to control the sharpness and the fuzziness.
Yeah.
This is the twilight zone. Oh, I'm sorry. The outer limits.
Outer limits.
I love that show.
We can control the length of the pattern. Raster, when we get the raster text, we can spread the raster out. I'll show you that in a moment. We can select 3 different patterns. Display, which you're going to put all the patterns one after the other. Number 1 is usually displayed over here on many scopes. On some scopes, number 1 may start over here, and the rest of the firing order may follow suit. They start 1, 3, 4, 2. But we'll look at that in a moment. Raster patterns is all the patterns one above the other. See, it's not quite in the right place. That should be over here. Superimposed puts all the patterns one on top of each other so you can see how much consistency there is between the patterns. We can go in and cancel out the cylinders. If everything works right today, like I said today, we can go in and cancel out the cylinders, one by one.
Oh, it's the Oscars.
Right? Oh, we can kill them all at once.
That's cool.
So we have a selection knob here. It's supposed to measure RPM and amperage.
All right.
500 amps, 100 amps. Notice the knob, the meter changed a little bit. Amp calibration. Sometimes people wonder, why do you do this? Why do I move the knob back and forth? know? Well, some of it is to adjust. Sometimes these machines set for quite a while, and what they use is a variable resistor or rheostat inside, and sometimes you need to move it back and forth to help clean the contact, because it sets for so long.
See?
Non-upfield 0 or not. Anyways, condition selector, 1, 2, 3, 4, that's the selection. Trigger resistance, auto tack dwell means it'll auto range on the RPM. It'll measure dwell on the top scale. Then you go to 12,000 RPM. On the bottom scale, 0 to 12,000. We don't have too many engines in the shop that will do that. The motorcycles will, though, huh? Yeah.
Hey, how much memory does this thing have?
Huh? How much what?
I'm talking about this thing.
How much memory?
Yeah, we're making a video, and it's like at 11 minutes. That's like...
All right.
Yeah, we won't split it. It'll be the whole thing. Now let's get the whole class. Yay.
We're going to edit it afterwards.
Yeah, we got to get some of you out of this.
This used to have a vacuum pump, but I don't think it works. Vacuum down.
Yep.
Anyway. All right. If somebody will start the car, we'll see if we can get some patterns. Black guy. Oh, yeah.
Take the glasses.
Right. I'm not real happy with the length, so I'll move the length a little bit, lengthen it out, so I can get a good picture of all the patterns. This is what's happening inside the ignition system and goes to the spark plug now. It's not recorded, it's not buffered. This is as it is happening. Each of these firing lines, voltage spike, is what's happening right now. I'll just brighten it up just a little bit. Sometimes you brighten it up, you might see a spike.
Oh.
Okay? If you see a high spike somewhere, something's going on. There's the auto tack.
Is it normal to see spikes? Like every now and
If you see
then?
a spike every now and then, it means you're, for some reason, got a high resistance.
Oh.
Okay? Right now we're running on the left side. See, we're on low pattern height, so we're on the left side. This is 5 kilovolts, 10 kilovolts, 15, 20, 25 kilovolts. Okay, on the right side, we're going 10 kilovolts, 20, 30, 40, 50 kilovolts. If we change over to the right side, it drops down a whole bunch.
Yeah.
We don't get a good picture though either, do we?
No.
We saw a spike. Wouldn't that indicate a high voltage? High voltage because of the resistance. Yeah. Okay. Right now we're running about 6, 7, 8 kV, 8 kilovolts. Yeah. So we're seeing the firing of the spark plug. That's what's called your firing line. This little line here is called the spark duration line. This is our coil condenser oscillations. Notice there should be about 4 to 6. We don't see it real well here, but there's usually about 4 to 6 oscillations come across. This is where the transistor turns on inside the module or igniter. Transistor turns on. You'll have some oscillations here. Comes across. At this point where the firing line is, this is where the current controlling transistor turns off. We collapse the magnetic field inside the ignition coil. And we get the high voltage spike coming out of the ignition coil. So right here, transistor turned off. Let's see, we got, we're looking at 4.
So each line is one
Each line is a cylinder. Each one of these events, right, from here to here is one cylinder. Okay, number one firing line is over here right now. On this machine, it's a little different from the other ones. This is an older machine. The firing line for number 1 is here. The rest of the pattern for number 1, the spark line, coil condenser oscillations, the dwell period, is all over here for number 1. Now this machine's dumb. It don't know what the firing order is.
Poor guy.
So you have to
Look it up.
know what the firing order is. So what firing order of this car is? 1, 3, 4, 2. Okay, so you're looking at number 1, number 3, number 4, and number 2 in the firing order. Not the sequence of the cylinders. 1, 2, 3, 4. It's in the firing order because you're taking the information as it's happening off of the distributor, off the coil wire. Right?
Yeah.
Remember, the silver one, the silver clamp, this is your pattern pickup. The red clamp, synchronizing it to number 1. Now, can I do that on a different cylinder? Can I move that red clamp to another cylinder?
Yeah.
Yes. Sometimes you might want to do that. Let me step back there. I might want to do that. I can't get to number 1. So I'll go to another cylinder. Because you realize when you go to another cylinder that you're starting out on that other cylinder. See, now I put it on number 4. Is number 4 companion to 1? No. Yes, it is.
Oh no, it is 1, 4, 3,
1, 3, 4, 2.
So 1 and 3 be a companion to it?
No, 1 and 4 are companion, 3 and 2 are companion.
Oh, yeah, you're right.
Okay?
You're right.
I could have picked 2, I could have picked 3. But I just have to keep in mind now, this is number 4, right? See, 1, 3, 4, 2, so that's 4. This is 2, 1, and 3. You have to keep that in mind. That's a little more difficult. In some cars, you can't get to what you want. It's like somebody had a Lexus V6 in here, right? Somebody had a Lexus in here? Is number 1 on the front or the back? Number 1 on the back.
Oh, you
hard to get to, huh? Well, since you have a distributor on that? You have a distributor on that?
No pressure, man.
Coil on flux. So you can't get back there to number 1 very easily. So you could go companion cylinder, and that firing order is 1, 2, 3, 4. So 1 and 4 on that V6 are companion. You could have gone to number 4 and got your patterns. Okay? So the chrome pickup is for your pattern, all your patterns. The red pickup, same provider. Take the red clamp off. Okay? Usually what it'll do, it will hunt. It'll move back and forth because it doesn't have the synchronizing pickup. Okay, so you don't know exactly what number 1 is. So let's put it back at number 1. Number 1?
Number 1.
And sometimes they'll just roam back and forth trying to figure out where it's at, not be synchronized. So red clamp is synchronizing your patterns according to the firing order, firing sequence. That's a display pattern. It's also called the parade pattern, parade or display. All the patterns one after the other. The raster pattern put all the patterns one above the other. 1, 3, 4, 2 in the firing order. Some do it this way. 1, 3, 4, 2. On this scope, it's 1, 3, 4, 2. So you have to be familiar with the scope you have. Because there's some other scope manufacturers out there that do different things. Now, if I want to get the pattern in the area where I can read things, now you notice at the bottom here, it has things in degrees. 4-cylinder, 6-cylinder, and 8-cylinder. What this is good for is measuring the dwell, or the coil saturation time. In the old point type ignition systems, you look at this and kind of get a relationship, dwell over here and dwell here should be pretty close or the same. Okay?
He needs help.
I just need to move it over a little bit so it lines up precisely. And starting it up.
Oh yeah, I can hear you.
So one whole cycle's in there. So if we were to measure the dwell right now, dwell would be for 4-cylinder, about 15, 20 degrees. That's 6-cylinder scale down here.
Yeah.
8-cylinder scale, 4-cylinder. I think this car runs somewhere around 10 degrees, but it's showing 20 as your dwell period.
Yeah.
I think it actually runs about 10 at idle.
I don't know how to zoom. Whoops.
Good picture. Come over here to do our dwell.
Wait, how do you zoom?
We're not reading dwell here.
Oh, all right then.
So we are reading RPM up here, about 920. 900, 920. Superimposed, but all the patterns one on top of each other. This is where you can come in and look at the spark line, see if they're pretty close to being even. Okay? You can look at your coil condenser oscillation. You should have 4 to 6 oscillations.
We'll figure it out later.
Okay? The 4 to 6 oscillations means that the coil windings are in good condition. If this was a point-type ignition system, you'll see a definite 4 to 6 oscillations. You can see oscillations in there. Your primary windings are good, your secondary windings are good. There's your basic secondary windings, primary windings, and the coil. So you need to have these oscillations in here. I don't know if we can lengthen that out a little bit better. Move it over. But you can see the oscillations up and down. The oscillations are also called inductive ringback. Anytime you have a coil of wire, and you energize it, and you turn it off, you're going to have oscillation. You're also going to have a voltage spike. A voltage spike.
Spike.
Anytime you have a coil of wire, coil, winding a wire, ignition coil, relay, anytime you have a winding a wire and you have power to it, and you turn it off, you're going to have inductive ringback. You're also going to have a voltage spike. It's like injectors. Injectors are basically a solenoid with a winding wire. Injectors.
It first creates magnetism, right? And then after you turn it off.
Right. And when that collapses, you get the voltage spike. And in injector, you can get 70 volt voltage spike. You want that voltage spike going back to the computer? No. So they'll put a diode, a clamping diode in the circuit to run it to ground so it don't go back to the computer. It's 70 volts, so, oh, shoot. Damage the computer.
It's a long-ass video, though.
But here, we want to see those oscillations. Again, our voltage spike is...
Why not? After you guys didn't even pay attention.
Right here. Where's our voltage spike here? How many volts? 7 to 8 kV? 7 to 8,000 volts?
Do you?
That's our voltage spike.
8,000.
So your raster again, stack patterns, raster pattern. The voltage is not real reliable here because you can't get a real good relationship, but what you're looking at, your spark line, your coil condenser oscillations, this is the amount of time that the energy is dissipating. This is called, we'll go back to the, right here, firing line, spark duration line. This is called your firing section. It's only for a few milliseconds. It's your firing section, the time that you're jumping the gap, maintaining the spark, which is only for about 2 or 3 milliseconds, and then you go across the condenser oscillation. The energy is going to dissipate. Right here. That's your spark line. The firing line, and this line here is your firing section. This is your, from here to here, called your intermediate section. Energy dissipation. Energy is dissipating. This is called your dwell section, or coil saturation time. As an electronic, we don't have points.
Right.
We have dwell,
Right.
because we're allowing the coil to saturate, build up saturation.
Right.
It is measurable. I don't care whose ignition this system is, somehow it is measurable. You might have to just find the right leads, like on the Camry, find the right lead, but this wall section is measurable. If we were to raise the RPM on this engine, what would happen to this wall section?
It'll get smaller.
It'll get larger. Okay.
I think you said when you raise the RPM, we have less dwell time.
You have, on a point-type ignition system, you will have less dwell time.
Why don't we do it?
You will have less saturation time. This is the advantage of electronic ignition systems, because now they can allow more time for the coil to saturate at high RPM. So that was a drawback on point-type ignition systems. We're only going to have so much time, no matter what. Higher RPM you go, you're going to have less time. You're going to have less saturation. And this is why point ignition systems were not real good, anything about 5,000, 6,000 RPM. And why they went to electronic. Can you raise your RPM up just a little bit? Raise it up and hold it. Somebody? Yeah. Now you can see the dwell has expanded quite a bit just by raising the RPM.
Yeah.
That's giving us more coil saturation time at a higher RPM. Go ahead and let it idle.
Oh.
Okay? Points won't do that.
It'll get smaller, right?
No,
It'll stay.
it doesn't change. But the amount of time for the saturation does. It's like I was trying to show you on the board the other day. The point-type ignition system at idle, it's not a big deal. We're allowing, it takes 10.1 milliseconds for the coil to saturate. We're allowing 11. As the RPM goes up, 1,000 RPM, now we're only allowing 9.9 milliseconds for the coil to saturate. The dwell didn't change. Dwell is going to be fixed. On a point-type ignition system, because of a V8, it's going to be 30 degrees for a V8. 30? On most V8 is about 30. 28 to 32 on a GM, 26 to 30 on a Ford, or Ford product. It's not going to change. It shouldn't change.
The amount of saturation is
No, the dwell is going to be the same. The amount of time that the points are closed. Dwell is a measurement in degrees of distributor shaft rotation that the points are closed. The time that you're allowing the coil to saturate is going to change because your dwell is fixed. You're not going to expand the dwell as the RPM goes up, and it's not going to contract as the RPM goes down. Dwell is going to stay the same. The point gap is not going to change. The point gap is going to stay the same. So what happens is the relative time that you allow for the saturation to take place. Just like at 2,000 RPM, the amount of time you're allowing the coil to build up saturation is now 4.45 milliseconds. At 4,000 RPM, now it's 2.25 milliseconds.
So on a point ignition system, the higher the RPM, the weaker the spark will get, right? And on electronic, the higher the RPM, the stronger you might.
You're going to keep that nice strong spark. Okay. At 6,000 RPM, you're only allowing almost 2 milliseconds for the coil to saturate. And this is where the point-type ignition system would fail, is that somebody gets sparked, somebody won't.
Nah, damn, we killed the memory.
Killed the memory, used it up.
Yeah, we only got like 30 seconds left.
Really?
Yeah, it's counting down. 41, 40, 39.
Everybody start saying,
Cheers.
everybody start saying goodbye then.
Bye.
Point-type ignition system.
That's how he left.
You're going to have a lot of time for the coil to saturate. The higher the RPM, the less the time. At 6,000, 7,000 RPM, 8,000 RPM, the standard point ignition system failed. The engine would crap out. The valve springs were also the weak part too. They designed everything around each other. high performance engines, you have to have better cloud strength. They also came out dual point ignition system